Howdy, stargazers, and welcome to Star Trails. I'm Drew, and I'll be your guide to the night sky for the week of October 26th through November the 1st. The calendar is turning toward November now, and the stars have that unmistakable autumn clarity. The air's a little sharper, the nights come earlier, and the sky feels deeper, like it's holding its breath before winter sets in. Also, Halloween is later this week, and for our final episode of October, we're going to examine another eerie topic. In a universe as vast as ours, we ask the question, where is everybody? We're not looking for little green men or flying saucers necessarily, but with all the potential worlds that surround us, why haven't we received any indication that someone or something is out there? Could it be that we truly are alone? It's called the Fermi Paradox, and we'll take a detour into that and more in the second half of the show. Before I get into the night sky report for this week, I just have a quick update on the show website. If you're a new listener to the show, you might be wondering which other episodes would be good to go back and listen to. So I've created a section on the website, startrails.show, with resources for beginning astronomers and new listeners. On the site, you'll see a new option in the top menu called Start Here. On this page, you'll find a collection of my favorite episodes from the more than 80 we've published since last year. Some of these are very much aimed at the new astronomer, while others cover topics that might be a bit off the wall but still thought-provoking. I've also compiled a collection of links that new astronomers might find helpful, from some of the stargazing apps I use to websites that are helpful for astronomers at any skill level. And as always, if you have a question or comment about the show, you can use the contact form on the site to send me feedback. I really enjoy those listener questions. So with that announcement out of the way, let's see what's up in the sky this week. The moon begins as a slender waxing crescent and grows brighter each night, reaching its first quarter phase on Wednesday. Early in the week, you'll still have dark evening skies, making it a prime time for faint objects and binocular or small scope observing. By midweek, the moon will shine high at sunset and show off sharp craters and mountain ranges along the terminator, the line between lunar night and day. After that, the moon transitions into a waxing gibbous, staying up later into each night. That brighter moon may wash out faint deep sky targets, but it opens great opportunities for lunar surface photography or simply enjoying the moonlit landscape. Farther out, Saturn is still ruling the evening sky. You'll find it glowing a soft yellow-white in the southeast after sunset, climbing higher through the night. Even a modest telescope will reveal its rings and a few of its moons. Jupiter rises later, around mid-evening, and dominates the eastern sky. If you're up late or awake before dawn, it's one of the showstoppers. Mercury makes a fleeting appearance this week. On the 29th, it will reach its greatest eastern elongation. That's its furthest angular separation from the Sun in the evening sky. Keep a clear view toward the western horizon just after sunset, about 30 or so minutes after sundown. If the sky's clear and the horizon is free of trees or buildings, you might spot the elusive twilight planet. Mars is fading, low in the west after sunset and chasing into twilight. And Venus is now a morning star, rising just before dawn in the east. It's worth a glance if you're an early riser. Our solar system is still hosting two special guests, and if you've been active on any astrophotography forums lately, you've probably seen some beautiful images of at least one of them. Our photogenic visitor is Comet C2025A6, or Comet Lemmon. Discovered earlier this year by the Mount Lemmon survey, it's on a long-period orbit of roughly 1,150 years. It's currently brightening and may be visible even with the naked eye under very dark skies, though binoculars will make it much easier to spot. For observers in North America, it's best after sunset in the northwest to west sky. It's low right now, but becoming more accessible. If you have a clear horizon, try locating it with binoculars in the constellation Boötes, a little more than 5 degrees northeast of Arcturus. And if you can't find it, just keep enjoying those stunning images other astronomers are capturing. It has a well-defined coma and a long tail that looks like it's shimmering in a cosmic breeze. The second visitor that has many people intrigued is interstellar object 3I Atlas. This object arrived from outside our solar system and it just cruised past Mars a couple weeks ago. It's classified as an interstellar object because its trajectory is hyperbolic, meaning it's not bound to our sun. And it's only the third such object like this we've ever recorded. Scientists are studying it carefully, though for backyard observers it's faint and difficult to spot. The buzz about it is largely thanks to its interstellar origins. You may have seen some of the speculation and conspiracies claiming it might be artificial or alien in origin, but mainstream science strongly supports the view that it's a natural body. So while it's a fascinating object to follow, keep your expectations grounded because it's not much to look at least right now. Now for the constellations and the quieter stars of fall. We've mentioned them in the past few episodes, but high overhead you'll find the Great Square of Pegasus, that large, distinctive square shape marking the winged horse of myth. From its top corner you can trace a line northeast to the Andromeda Galaxy, our galactic neighbor. A pair of binoculars will help you find it. North of that, you'll find Cassiopeia, the queen of the northern sky, hanging high from mid-northern latitudes. Just below Cassiopeia lies one of my favorite binocular targets, the double cluster in Perseus, a pair of star clusters bright and compact, easily enjoyed even in modest skies. The Milky Way isn't as obvious as it is in summer, but if you're under dark skies early in the week while the moon is still thin, you can trace its faint river starting south and moving through Cygnus, Cassiopeia, and into Perseus before it drifts into the northeast. It's a subtle beauty, less dramatic than the summer belt, but rewarding all the same. Meteor activity from the Orionids is tapering off, but don't rule out a stray meteor before dawn. If you're out late, keep a casual eye toward Orion rising in the east, and you may catch a bright one. As always, to truly appreciate the fall sky, take a moment between targets. Let your eyes adapt to darkness for about 10 to 15 minutes. With the heat of summer gone, the air is clearer and your view reaches farther. Next up, we'll step into that stillness more deeply, exploring the vast silence between the stars and why, in a universe so old and full of worlds, no one seems to be there to answer us. There's a kind of silence in the cosmos that feels different from any other kind. It isn't peaceful or serene, it's unsettling. It's the silence of absence, the long echo of a question that's never been answered. We call it the Fermi Paradox, the contradiction between how likely life seems to be and how alone we appear to be. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos. The conversation turned to UFO sightings, and Fermi simply asked, "Where is everybody?" It was both a joke and a revelation, because by that time, astronomers already knew the galaxy was ancient, 10 billion years older than the Earth, and vast beyond comprehension. Even if just a tiny fraction of those stars had planets and an even tinier fraction had life, shouldn't we see some sign of it? And keep in mind, at this point in astronomy, we hadn't discovered a single exoplanet. That breakthrough was still more than 40 years away. A decade after Fermi's question, astronomer Frank Drake tried to make sense of it mathematically. In 1961, he hosted a small meeting at the Green Bank Observatory in West Virginia, the first gathering devoted to the search for extraterrestrial intelligence. He scribbled a simple formula on a blackboard to structure their discussion, never imagining it would become iconic. That formula became the Drake equation. It looks intimidating at a first glance, full of variables and symbols, but the idea is straightforward, and it's solvable using basic algebra, provided you can fill in the variables. Drake broke the problem into 7 factors. How many stars form each year? What fraction of those have planets? How many of those worlds could support life? How many of those worlds indeed produce life? How often life develops intelligence? How often intelligent life develops technology? And finally, how long such civilizations can send detectable signals into space. Simply multiply those together, and you get an estimate of how many civilizations might be communicating right now in the Milky Way. But the genius of the equation wasn't its precision, it was its humility. It showed us exactly where our ignorance lay. Every variable is a mystery to be solved, and each new discovery, exoplanets, biosignatures, radio surveys, tightened the numbers a little more. Right now, if you plug some hopeful numbers into the equation, you might get a few dozen civilizations in our galaxy right now. If you use more careful or skeptical numbers, you might end up with a number less than 1, meaning we could be the only ones here at this moment. The problem is, most of the numbers in the equation are giant question marks. We don't know how often life begins, how often it becomes intelligent, or how long a civilization like ours stays detectable before it disappears. The math is strangely easy, it's the facts we don't have. Drake didn't stop there. He also co-founded Project Ozma, the first modern SETI experiment using the Green Bank telescope to listen for radio signals from 2 nearby stars. The effort was modest, just a few months of listening, but it sparked something profound. Soon after came the idea that we shouldn't just listen, but speak. In 1974, the Arecibo Message was transmitted toward the globular cluster M13, a tightly packed group of stars 25,000 light-years away. The signal, composed entirely of binary digits, encoded the numbers 1 through 10, the elements essential to life, DNA's double helix, a stick figure representing a human, the solar system, and the Arecibo telescope itself. It was symbolic more than practical. By the time the signal arrives, M13 will have drifted away, but it was a statement: we are here. A few years before Arecibo, in 1972 and 73, NASA's Pioneer 10 and 11 spacecraft became the first human-made objects to leave the solar system. Each carried a small aluminum plaque etched with a map of our location in the galaxy and the image of a man and woman greeting whoever might find it. The Voyager 1 and 2 spacecraft went further. Each carried a gold-plated record sealed against time containing music from Bach to Chuck Berry, greetings in dozens of languages, and sounds of our planet, such as wind, rain, laughter, thunder, bird song, and even the heartbeat of a mother and child. Together, these were our cosmic time capsules, drifting ever outward at 17 kilometers per second, bearing a message for listeners we may never meet. We covered the Golden Record in episode 52 and included many sounds from it in the episode, so go back and check it out if you missed it. By the 1990s, the search took a new form: digital crowdsourcing. The SETI Home project turned ordinary computers into a distributed radio telescope. Millions of volunteers, and I was one of them, and maybe you were too, downloaded screensavers that processed chunks of data collected by the Arecibo Observatory, searching for narrow-band signals that might indicate alien transmissions. For 2 decades, it quietly scanned billions of frequencies running in the background on computers around the world. Humans, united by curiosity, gave their idle CPU cycles to the search for cosmic company. It was science as global collaboration and the largest volunteer computing project in history. Sadly, SETI Home never discovered any alien signals. The program went into hibernation in 2020, but its legacy continues in new AI-driven searches like Breakthrough Listen, which now monitors billions of stars with unprecedented sensitivity. And yet, the silence persists. Which brings us back to Fermi's haunting question. Some have speculated a great filter, a stage in evolution so perilous that few make it past. Perhaps intelligence carries the seeds of its own destruction. Ecological collapse, nuclear war, or even artificial intelligence run amok. If the filter lies behind us, we're lucky. If it lies ahead, the silence may be a warning. Others suggest more poetic explanations. Maybe civilizations retreat inward, turning to virtual worlds richer than reality itself. Maybe they transcend physical space altogether, existing as patterns of energy or information. Or maybe the galaxy is a dark forest where every civilization hides in terror, knowing that to announce their presence might invite annihilation. In that sense, silence isn't failure, it's a strategy. And then there's the humbling possibility that we simply don't know how to listen. Alien intelligence might communicate in ways beyond our comprehension, through neutrinos or gravitational waves or quantum entanglement. Their language could be encoded in magnetic fields or stellar oscillations. To them, our radio beacons might be as primitive as cave paintings. Personally, I believe in the simplest explanation. Space is unimaginably vast. The nearest star, Proxima Centauri, is more than 4 light-years away. That's about 25 trillion miles. Even if we sent a message traveling at light speed, it would take more than 8 years for a round-trip conversation. And that's our closest neighbor. The rest of the galaxy stretches across 100,000 light-years. Also, radio waves, like light, weaken as they travel. What begins as a clear signal near its source dissolves into noise over cosmic distances. If you're involved in ham radio, you've likely seen signals fade dramatically over just hundreds of miles. The signals that escape Earth fade into the background hum of the universe long before they reach most of the stars we dream about. It's not like the beginning of the movie Contact, where we zoom into the solar system from light years away, hearing our earliest broadcasts echo through the void as clear as they were the day they were made. It's entirely possible that the cosmos is teeming with voices, each calling out into the dark, but none strong enough to bridge the gulf between them. 1 million lonely transmitters, all speaking, all unheard. Maybe the idea of that loneliness creates a feeling of existential dread. And here's another eerie Halloween thought. When you look up, much of the starlight falling on your eyes began its journey long before humans even existed. It crossed unimaginable distances, unbothered by our loneliness, carrying no reply, just photons from ancient suns. And the silence isn't nothing. The quiet between the stars may be the most profound message of all. A reminder that the universe is vast enough to contain both our fears and our hopes, our solitude and our longing. If the stars spoke to you this week, or if a question's been on your mind, I'd love to hear it. Visit startrails.show, where you can contact me and explore past episodes. Be sure to follow Star Trails on Blue Sky and YouTube. Links are in the show notes. Until we meet again beneath the stars, clear skies, everyone.